Hey guys, this is SyedaZaidi, and today I'm going to be talking about 10.7 in pre-calculus, and this topic is about polar coordinates. So this topic is based on the trigonometric functions like sine, cosine, tangent, cosecant, secant, and cotangent. So basically all these 6 trigonometric functions are going to be involved in this topic. So it also involves basically this polar coordinates are really different from the original graph. For example, you're trying to find slope in the original graph, right? It's mostly like lines, just straight lines, like inverse or directive or linear or nonlinear. But in this kind of polar coordinate, so polar coordinates are really different. It has like different x and y points, very different actually in my opinion. And it's not that, basically in this graph it doesn't really involve the same points as you would find from the normal graph. It's mostly like involving like sine, cosine, like pi, involving pi in these equations. For example, in some other topics we talked about how we talked about sine graphs and tangent graphs, and they have pi involved in them as points. But this one we're just gonna talk, kind of similar to that. But let me just give you like a review of what it looks like what you need to expect, or what you need to do, or what you need to know before you start solving polar coordinates kind of questions. So first of all, the only main thing you need to focus on is r and theta. Now r and theta is just like x and y, but you see how I talked about how it's more different than that. So basically r is the directed distance from O to P. Now O to P is basically, this is what I'm talking about, O to P. Okay, this figure is what I'm talking about, O to P, so you guys know what the visual kind of picture you need to know when I'm talking about, O to P. And I also involve like the key points of r and theta, so you know where they are located in this figure and how you would interpret in the graphs. Now theta is actually a directed angle counterclockwise from polar axis to segment OP. Okay, so r is like a directed distance, from O to P, and the angle, the theta part is basically a directed angle counterclockwise, from polar, let's say from polar axis to segment OP. So right here you see this is O, okay, and this is P. You see how it's like O to P, so R is O to P difference, O to P, you know what I mean, like R is a directed distance, so it shows like a distance of O to P, and theta is basically the angle of O to P. It's O to P is the angle of, so if you go back in geometry, you know that O and P is basically the angle of that, as in, OP. And this is the polar axis, so, and this is P, which is equal to R and theta. This is one area I could actually show you guys as a visual picture of what I mean by O to P and R and theta, because this has never been in a different situation before, and this is actually new to me too. So now you know how it looks like in a visual representation, and let's get started with the problems. Okay, so this is the first problem in this unit, and this unit is talking about, or asking us to convert the point to rectangular coordinates. Now that means that we have to, now this is the original coordinates we have, but this is a polar coordinate, but we have to change it to rectangular coordinates. Now this one is a little more, I guess you could say, more steps to do, because you're trying to find the rectangular coordinate, which means that there's more steps in order to solve it. So if you see in the graph, it will be a little different if you expect it to be like that. But since there's no graph, we're gonna have to try finding it from solving. So if you think about it, x is equal to r cosine theta, right? So in order to find for x, we're gonna have to do x equal to 6 cosine 3 pi over 2, because we have 6 as x and 3 pi over 2 is y, okay? So we have that, right? Equal to 0. And now y equals to r sine theta would be equal to y equals to, well, 6 is basically r. So else it would be r theta. Remember that? It's not x and y, it's r and theta. So y equals to 6. And then sine this time, because, you know, cosine is x, sine is y. 6 sine, yeah, 3 pi over 2. Now, when you solve for that, it will give you an approximate of -6. And, sorry about that. So, when you try solving for this problem, it will give you a -6 as your final answer for this. So that means that the rectangular coordinates, now if you think about it, 6 cosine 3 pi over 2 is equal to 0, right? So when you try doing it on the problem, or as a rectangular coordinate, so that means that RC, which stands for rectangular coordinates, is equal to 0 and -6 as your final coordinates answer. And so this is how you solve for this problem. Okay, so this problem consists of converting the rectangular form to polar form. So this is already in rectangular form. Now we have to do the opposite and then turn it into a polar form. Now last time in the first question, it was already in polar form. Then we have to convert it to rectangular form. Now, what I'm saying here right now is that now you have to try it. Now it's a reverse question, okay? So this one is a little more depth instead of the last one, because the last one was just r and theta, it was already in a point form, but this one is not already, it's not in a point form, it's actually in a y equal kind of form. So now the formulas we're going to be using is x equal to r cosine theta and y equals to r sine theta. So here what we're going to do is that we're going to use the y equals r sine theta for this one, because it's y equal to 3 square root of 3x equal to 3, y equals to the square root of 3 and then x, okay? So we're going to use the y equals r sine theta, okay? Or actually, we could also use the cosine too. Basically, we can use both of them, but okay, let's just try solving it when we go through the steps. So, right, okay, so the r sine, let's do both of them at the same time. That would make, yeah, actually that would make more sense. Okay, so we could do r sine theta equals to square root of 3 and then r cosine theta. So this is y and this is x. And now we're gonna have to make them together. So basically divide them together, right? So it'd be like cosine here and then cosine here, theta, theta. And if you think about it, in total, it would be sine theta over cosine theta. Now this one is actually equal to, actually let me do that then so you know. So let me just finish this first. Is equal to, well, we have square root of 3 left, so square root of 3 r over r, because we have all these 3 symbols left. So this is a square root of 3 and then r division, r over r. Now if you think about it, sine over cosine is actually equal to tangent. So tangent equals sine over cosine, but this is not the, okay, listen. Without the tangent, this is what you will get when you divide it by cosine. But now I'm just saying that tangent is equal to sine over cosine. Okay, that's what I'm saying. Cotangent, if you remember, is actually cosine over sine, so it's not cotangent. And these are the only two trig function I can think about that has 2 divisions, or sine and cosine together. Cotangent is not this, but tangent is. So we're gonna have to find tangent. So basically, it just cross this out and make it tangent. Okay, so it's be tangent equals the square root of 3 r and r. So that means that it'll be tangent equal to, let me put the theta here. Tangent theta is equal to the square root of 3. And now, to solve for theta, we have to actually do the inverse of tangent, which would be the arctangent. So we're going to have to substitute it to arctangent instead. So arctangent and then square root of 3 of arctangent. And if you think about it, arctangent, if you put it in a formula, or if you solve it by yourself, pretty sure it would be a pi over 3 kind of answer. So when you solve it for this, you will get it approximately, actually with theta equals arctangent. So when you solve for theta right here, it would equal to pretty sure it's pi over thirds, and this is what you will get as your final answer. And this is honestly what you have to do for the steps. So like first identify the formula you're going to be using. So r sine theta, which is x, and then y equals cosine theta, which is basically y. And then when you divide them together or do anything that will make it more sense for you, and then divide it by that, and you will maybe get cotangent or tangent. Depends on what kind of question you have. And then just try simplifying everything, reverse it to arctangent or arccosine or arcsine, doesn't really matter. It depends on what question you have, and then you will get your answer. So basically, in the summarization, the answer for this problem is theta equals to pi over thirds. Okay, so now in this problem, it says convert the polar equation to a rectangular form. So now this is the opposite of what we were doing before. So you see how it's mostly like this topic is mostly about rectangular forms, changing into a polar form or rectangular form. Depends on what question you get. So this one is actually saying convert the polar equation to rectangular form. So this one, now we have to convert it to rectangular form instead of the polar form. Now this is already in polar form, so that means polar equation actually. So now we have to change it to rectangular form. Now what I'm going to use on this equation is we're going to be using maybe the y part, because actually, yeah, because we're going to use the y part because cosine is equal to y. I'm so sorry, x is equal to cosine. So we're gonna be using x equal to r cosine theta, okay? Not y. Remember, y is equal to r equals sine theta. I was just mixed up with what I was doing, what I was thinking about. But cosine r, so basically x equal to r cosine theta. So because cosine is always in the x form, so that means that we're gonna have to change it to r cosine theta as x. So what we're gonna do is that we're gonna have to do step by step and make a sense, okay? So first that we're gonna do is we're gonna do r. Okay, my marker is not really in the best form right now. R minus r cosine theta is equal to 3. So we have r equals 3 over 1 minus cosine theta. So this is like a trigonometric kind of question. Yeah, okay, so we have r minus r cosine theta equal to 3, okay? Then we're gonna have to do the square root of x squared plus y squared, because we're doing step by step, okay? So x squared plus y squared minus x is equal to 3, okay? Then we're gonna have to add, I think, I'm pretty sure. Now let's try adding on both sides. So we're equal to 3 plus x, because 3 plus x, see? Now after that, we're gonna have to then simplify in the whole form. So it would be x squared plus y squared. Okay, also we have to do, okay, yeah. So if you do it in that form, it would be then, in that form, that means it would be 3 plus x and then square root. So 3 plus x squared. And when you do that, it will give you, now if you simplify again, now simplify 3 plus x squared. So 3 times 2 is what? Is 6, x squared, and then 3 times 3 is 9. So it would be x squared plus 6x plus 9 when you distribute and simplify. When you do the distribution property in this part. And then when you distribute it to x squared plus 6x plus 9, then we're gonna have to simplify again and think about what we would change it to a y squared form. So in a rectangular form, which is basically y squared or y equals to something. Okay, so that means that in this form, it would be y squared equal to 6x plus 9 when we cross out x squared. And yeah, this is how you solve for this problem. And basically all these steps include many, so don't forget to, because it's really easy to make a number mistake, only one number, and it would just cross out everything. It would just make the whole equation wrong. So remember to really focus on what numbers you have so you don't make a mistake at the end, because if you do, you'll waste all your time solving for the wrong thing you're looking for. So always focus on the numbers, and this is the answer for this problem.